Hey students, in this video we're going to talk about section 10.5, which is about box and whisker plots. Our learning target today is I can display and interpret data in box and whisker plots. So a box and whisker plot represents a data set along a number line by using the least value here, the greatest value here, and the quartiles of the data. Remember our quartiles, we have the median, which is called quartile 2 and splits the data in half. We have the first quartile, which is the median of the lower half, and the third quartile, which is the median of the upper half. A box and whisker plot shows the variability of a data set. It shows how spread out it is. The 5 numbers that make up the box and whisker plot are called the 5-number summary of the data. So our least value, first quartile, median, third quartile, greatest value, those 5 numbers are what we need to make a box and whisker plot, and they are called the 5-number summary. So we're going to start off with example 1, make a box and whisker plot for the ages in years of the spider monkeys at the zoo. So I need my least value, greatest value, median, and quartiles. So what I'm going to do is first put the data in order from least to greatest. So I've got 14, 15, 20, 26, 27, 30, 30, 30, 3 of them. 33. I wrote 35, but I said 33. Let's fix that real quick. All right. So next we have 33, then 35, 36, and 38. So my data is ordered from least to greatest. So I need the least value, which is 14, the greatest value, which is 38. I need the median as well, so let's work on that. So I'm going to count into the middle, moving my fingers in one at a time. I get 2 numbers in the middle, 30 and 30. When I have 2 numbers in the middle, I add them and divide by 2. I find the mean of them. Because the numbers are the same, I know that it's going to be 30. So the median or quartile 2 is 30. Okay, so that's my median in the middle. Now I need my first quartile and my third quartile. So my first quartile is the median of the lower half only. Again, there's 2 numbers in the middle, so I'm going to take both, add them, 20 plus 26, and divide by 2. That's going to be 23. And that's what's halfway between 20 and 26, so that makes sense. So that's quartile 1. And now we're going to find quartile 3. That is the median of the upper half. So again, finding the middle of the upper half, I have 2 numbers, 33 and 35. So I take both, add them, and divide by 2. I'm going to get 34 because that's what's right between 33 and 35. And that is quartile 3. So I have my 5-number summary: least, quartile 1, quartile 2, quartile 3, and greatest. Now I need to actually use these to make my box and whisker plot. So a box and whisker plot appears above a number line. So we're going to draw a number line first. And on the number line, I'm going to label it years, age in years, because that's what these numbers are representing. Now I need to be able to plot all these numbers from 14 to 38. So I'm going to go ahead and start my number line at 14, and I'm going to make each tally mark worth 2. So I'll go 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38. Perfect. So I have my number line. Now I'm ready to actually create my box and whisker plot. So I'm going to plot all of my values. My least is at 14. Quartile 1 is at 23. Quartile 2, the median, is at 30. Quartile 3 is at 34, and the greatest is at 38. So I have all 5 numbers. Now where does the box go? Where do the whiskers go? The box goes from quartile 1 to quartile 3. And the median is the line that is inside that box. The whiskers connect the least and the greatest values to the box. So my box goes from quartile 1 to quartile 3. I draw a line through my median, and my whiskers connect the box to those least and greatest values. Box and whiskers. All right, next it says that the figure shows how data are distributed in a box and whisker plot. About 1/4 of the data are in each whisker, so a fourth here and a fourth here. About half the data are in the box, a fourth in each side of the box. So a fourth, a fourth, a fourth, a fourth. All together, that creates the entire data set. All right, so we're moving on to example 2. It says the box and whisker plot shows the body mass index BMI of a 6th grade class. What fraction of the students have a BMI of at least 22? So at least 22, that means 22 or higher. So just this whisker. And remember, we learned that 1/4 of the data is in each whisker. So my answer is about 1/4. Then it asks, are the data more spread out below the first quartile, so below here on that whisker, or above the third quartile, so above here, this whisker? Explain. So where do we think the data is more spread out? It's going to be in above quartile 3, above Q3, and that's because this is a longer whisker. It's showing that the data is more spread out. Because there's a quarter of the data here and a quarter of the data here, the same amount, but this whisker is longer, it's more spread out there. And finally, it says find and interpret the interquartile range of the data. Well, remember the IQR of a data set, the interquartile range is quartile 3 minus quartile 1. The ends of my box show me quartile 3 and quartile 1. So quartile 3 is there at 22, and quartile 1 is here at 19. 22 minus 19 is 3. So the interquartile range of the data is 3. It's showing us how spread out the data is here. Remember, half the data is in the box, so we can interpret this by saying the middle half of the data varies, or the middle half of the data vary by no more than 3. The middle half of the data is spread out by no more than 3 BMI points. All right, the last thing is the shapes of distribution. A box and whisker plot also shows the shape of a distribution. A skewed left distribution has a left whisker that is longer than the right whisker, and most of the data are on the right. We can see it's condensed over here, so most of the data is here. A symmetric distribution has whiskers that are the same length, and the median happens directly in the middle of the box, so it's even on both sides, or close to the middle of the box. And a skewed right distribution has a right whisker that is longer than the left whisker, and most of the data are on the left. We can see that this section is more squished together, so most of the data are here. Okay, so example 3, the double box and whisker plot represents the lifespan of crocodiles and alligators at a zoo. Identify the shape of the distribution of the lifespans of alligators. So it's not even requiring us to use the crocodile one here. We are only really looking at the alligator one here. So I want to describe what shape is that. Well, I see whiskers that are approximately the same length, a median that is approximately in the middle of the box. I would say that looks symmetric. This is a symmetric distribution.